Welcome to week 8 of Math 25. We're going to talk about how much to save for retirement. We got almost to this spot almost a week ago, I think, and kind of paused and did a bunch of review, which is fine. Now we're going to go on, and this will almost wrap up our topics. We have some things about markup and margin to do after retirement, and that will basically just be one class. It's on the table of contents, 2 topics, but they're very short. And then one student is going into psychology and could benefit from a little bit of probability. We can skip the weighted averages, expected value stuff if people want, or we can do that too at the very end. It might be more fun to do a playground or something. So retirement and then markup and margin will finish us up. So I will preface this by saying I am not a financial advisor. Don't trust me on how to retire well. These are just very general guidelines that people recommend in general. And I don't know any of the details of your household's finances, your parents' or grandparents' household finances. The goal of this class is just to tell you the kinds of things to talk about so that you can have more intelligent discussions with people about retirement. This isn't the specific numbers that work for your family. So with that caveat out of the way, the general rule is that at age 65, people should have saved $20 for each dollar that they will be spending beyond their retirement income. Most Americans will have at least a little bit of retirement income from Social Security and pensions and things, and then have $20 for every dollar beyond that. And that $20 comes from the fact that you need to have $1 for every year between 65 when you retire and 84. So if you are spending $40,000 a year, you need to have 20 times the 40,000 to get you those 20 years. The interest during those 20 years will normally pay for the rest of your life, age 85 and beyond. So you don't actually need money in the bank after 85. You're just trying to have enough money in the bank to get you from 65 to 85. A typical American has their expenses greater than their retirement income by $20,000 a year. So we'll take that number, multiply it by this 20, and we get $400,000. This again is specific to families, what your Social Security and pensions and all the rest is. But for the example problems, we're just going to say our characters in these hypothetical problems do a good job if they have $400,000 saved for retirement. We'll give them a thumbs up and be happy. We're going to look at 3 sisters, Cindy, Clara, and Chloe, and each has plans to save for retirement, but they're very different. Somehow, by the time they're 25, they have the ability to set aside $3,000 a year. And that's not realistic. Most people save very little in their 20s and more after their career gets established. But the sum of annuity due formula, remember that one, you're plugging in the same amount year after year after year. So as an estimate, to just start this kind of thinking, we're going to pretend they're setting aside the same amount every year. So the formula works nicely, even though in real life, it would be less in their 20s and more as they get older. So Cindy is saying, when I'm young, for 10 years, I'm going to put money into savings. Then I will stop saving and spend all $3,000 a year on vacations. Maybe her excuse is that when her kids get older, she'll enjoy the vacations more. Clara is the opposite. For 10 years, she spends all the money on vacations. She wants to vacation when she's younger. And then for 30 years, between 35 and 64, she'll put all $3,000 into savings. And the last sister, is it Chloe? I never remember how to pronounce that name. Chloe will always go half and half. Doesn't matter how old she is, she'll put half into savings and half into vacation. So we're wondering which ones get to that $400,000 goal. And to make it just typical, then they get 8% annual compound interest. 8% is about the historical stock market average. If you haven't seen the graph of the stock market over time from when that we talked about mortgages up above, then let me show you that very quick. So here's a graph of the stock market over time. And you see that this curve increases as the average, and it goes up an average of 8% a year. Some years it's above, and some years where I highlight in red, it's below. So these ups and downs tend to happen at about 7-year intervals, sometimes a little more, sometimes a little less. And the problem with being in the stock market is if it's in the red when you want to take your money out, then you're not getting as much as otherwise. So what people do as they retire is when they're young, they keep money in the stock market because it will eventually get equal to or above the average, and then you can take your money out. And when you get older and you might actually need the money, then once it's above this curve, you take your money out, say, good, it worked, and you put it in what's called an annuity or bonds or some other types of investments that don't grow as much, but have a guaranteed payoff. It's sort of like a savings account, but you get a little more. So if you are in your 30s, having your savings bounce up and down doesn't bother you. You just have to ignore it. Don't read the news about the stock market, and know that sometime before 65, you'll be ahead of the curve and you should take your money out and say, hey, it worked. Because 8% is pretty good. And there are lots of studies that show trying to play the stock market usually doesn't work. The best thing to do is just invest in the whole index and be patient. There's books in our class library, A Random Walk on Wall Street, that talks about that in accessible language for people who are not math or economics folks. But you don't want to be bouncy once you're, say, in your 50s or beyond, because you don't want it to be that now it's time to retire, but the stock market is below its curve. So hopefully you'll have cashed out by then. Anyway, so the 8% seems like a lot if you're used to a savings account, but that's actually sort of a normal amount to use for these calculations. So I'm going to grab this chart and paste it into our Jamboard. And we will do it 3 times, 1 for each sister. We also have 2 different formulas we'll be using. Sometimes we'll use the sum of annuity due formula. And sometimes we'll be using the compound interest formula. We'll have to decide which formula is the right one to use for each situation.
Could you make those a little bit bigger?
Make these bigger? Sure.
Thank you. That's good.
That's good. Okay. So we're going to start with Cindy because she's first on our list. So she has 2 parts. She has 10 years where she saves. And then she has 30 years where she vacations. So when she is saving for this first part, Each year she puts in 3,000 more. Which of the two formulas is that?
The compound interest.
No, compound interest is when you just have one amount and watch it.
Oh, then the sum of,
Sum of an 82.
yeah.
The compound interest is the second part. She will have a certain amount in the bank at the end of the 10 years. And she doesn't use that on her vacations. She's using the 3,000 extra she had from her income. So whatever she has at the end of the 10 years as the end of part A, that's just going to grow and grow and grow for 30 years, but without any extra help from her. So that's compound interest.
Okay.
So let's do them both. So for the first one, she puts in every year 3,000. The rate, remember, was 8%. It just told us that. The brackets, I'm going to write as big parentheses. We have a 1.08 again. And the exponent is 10 because it's 10 years. Close my brackets. And this is just 0.08. Don't put a 1 in front. If you didn't watch any previous videos and you're watching from home, these brackets, those parentheses, those are these ones. The ones with 1 plus rate we can ignore. That's easy just to put a 1 in front of the 8%. The other caution is some calculators, I have to push something right here to get down out of exponent land into the normal punching things. But most calculators, after you hit exponent and 10, as soon as you hit minus, then it knows you're not in exponents anymore. So be careful with how your calculator works. Anyway, take out your calculator now, punch it with me, make sure it works before you do homework. So 3,000 times 1.08 times parentheses 1.08 exponent 10. On mine, I don't have to come down. I just hit -1, close parentheses, divided by 0.08, and I get 46,000. $934.46. So of this $46,934.46, remember she put in 3,000 10 times. So 30,000 was her own, and the other $16,934.46 was the interest. So she's made about half of her money extra now. So this amount becomes the principal for part 2. Once she turns 35, she stops saving 3,000 a year. She uses her extra income on vacation, but she's not spending this. Or if she does, because she's getting a down payment for a house or something, she pays it back. So this is her money, and it's just going to grow and grow and grow and become her retirement money. So that's what compound interest formula does. There's only one amount that's put in at the beginning of the whole time period, and you just watch it without fiddling with it. Very different than some of annuity do, where every year you put in the deposit. Okay, so in this case, her final amount is that 46,934.46. And we multiply it by the interest rate per payout. We're working at 8%. That was just part of how the problem was defined. It said 8% in the problem. And the number of payouts, everything is annual. We don't have to do any fussing about months or weeks or stuff. Everything is annual. So it's 30 years, 30 times she gets a payout. So make sure your calculator matches. I'm getting $472,000, 285, and 37. Everyone else got the same?
Yeah.
Okay, so she made her goal. She got to the 400,000 that we're assuming a typical American. We don't know the details about her family's pensions and anything else, but she looks good. We're now going to do the next part, which is her sister Clara. So for Clara, the opposite happens. For 10 years, there's vacations and no savings. And then for 30 years, there's savings each year. Okay, here's a trick question. Which formula do we use when she's not saving any money?
The compound interest rate. Or am I wrong again?
It's a trick question. She's not saving any money. At the end of 10 years, she has 0 in her retirement account. So
Right.
no formula for part A for Clara.
Oh, okay, so
Okay, part B is not a trick question. When she's putting in the same deposit year after year after year, which of the two formulas is it?
the sum of annuity.
Yes. Okay, so she's putting in 3,000 a year. She also has that nice 8% average stock market rate. She's putting in the 3,000 30 times. So Cindy, remember, spent 3,000 times 10, 30,000 of her own money. Clara is spending 90,000 of her own money. So check with me, make sure your calculator works. 3,000 times 1.08 times parentheses 1.08 exponent 30 minus 1 close parentheses divided by 0.08 and 367,037.60. Did your calculators get the same answer?
I was writing it down.
Yes.
So this surprises most people who see it for the first time. Remember, Clara put in 90,000 of her own money, but she didn't get quite to the 400,000. So she had less savings than her sister, even though she put in much more of her own money. So the moral of this story is start early. Even if you can't save a lot when you're in your 20s, then it helps a lot to start early. It's worth it to save what you can. Questions about Clara's slide before we move on?
No.
Okay, so Chloe Oh, I still don't know how to pronounce that name.
I think
She,
Chloe's right.
she has only one situation. Doesn't matter how old she is, she always splits her extra money and says, I'm going to spend half of my surplus income on vacation and half of that on savings. So her principal is 1,500. She has that same 8% rate. Her years are all 40, the 10 and the 30 together. Everyone okay with this? Plugging things in before we do the answer?
Yeah.
I'll
Yeah.
make a note just because it'll be a little more confusing if you're at home. 10 plus 30 is 40. And that's why we have that 40 there. Okay, 1,500 times 1.08 times open parentheses 1.08 exponent 40 minus 1 close parentheses divided by 0.08. So 419, 671, 56. How did she do? Is it 419, 472? So Cindy had the most by a significant amount, more than 50,000 more. Chloe did better than Clara, even though she never had to save 3,000. She always got to go on a vacation each year. How much did she put in on her own? 1,500 times 40 is 60,000. She put in more of her own money than Cindy did, but less than Clara did. Again, it's reinforcing start early. She didn't save as much as Cindy early on, but she saved some early, and that put her ahead of Clara at the end. If you want to review these, they make great review problems, and the answers are here, so you can check things even if you can't find the slides. Okay, we're not done yet. Why is that one there? So Cliff is Clara's brother. He stops smoking at age 25 and decides to take the money he was spending on cigarettes and use it for his retirement. He used to smoke a pack a day at $5.70 per pack. I don't know what the price is currently. This is a couple of years old. How much money per year was he spending on cigarettes? So first, let's take that 570 and multiply it by 365 days. 5.7 times 365. So he was spending 2,080 and 50 cents per year. If instead he puts that in a retirement account every year, how much does he have? We need a percent rate, so I need this part of the problem too. So he's going to have a more modest amount. We're only giving him 6% instead of 8%. He is not quite as lucky with his stock market. to make this 40 look a little higher. I want to be very clear. Oh, okay. Everyone okay with the setup stage here?
Yeah.
So he gets $341, $41,000, 301 and 21. Okay, more morals of the story. So the reason we talk about Cliff is when people look at this Three Sisters problem, they say, this is a bunch of baloney. I don't have 3,000 a year to save. How realistic is this? And 8% is an average stock market return overall. What if I'm not as lucky and the stock market isn't quite as good for me? So Cliff is showing you that most people have something they can cut back on. In Eugene, it's often something like buying a fancy coffee at Dutch Brothers if you're not a smoker. But if you can find something and cut down a little bit, then you can probably scrounge more money than you expect and be saving early on. And as we saw before, saving early on is really what makes the difference to having lots when you retire. And we don't know anything about Cliff's household. Maybe he's married, maybe he has other people earning money, but ignoring everything else, just his cigarette money almost gets him the 400,000 that he wants for retirement. He's not that far away. So adjusting your budget, adjusting your expenses, making coffee at home, whatever it is, then you can probably get a lot of your retirement savings done that you haven't thought about before. Questions about any of that?
No.
Nope.
Let's do a similar one from the homework. So one that's kind of tricky is number 9. So Eugene has pretty expensive childcare. The big 3 childcare places cost about $13,000 a year.
Oh, you took a nap? You took a nap. Yeah.
So we're going to do a 2-part problem. We're going to use the sum of annuity due for 2 years. Because for 2 years, what happens if instead of spending the 13,000, we could somehow save that? And then we're going to use compound interest for 16 years and just watch what happens between the age of 2 and when the kid is 18 and going off to college. And we're going to be not very ambitious. We're just going to use our 5% interest rate. Because again, the stock market might average 8%, but that's assuming that you get out while you're ahead and transition to something like annuities or bonds that aren't risky. And with only 18 years as a time frame, we have less flexibility of when to get out and move to boring investments. So we'll start with the sum of annuity due formula. Make it a little smaller just to fit on the screen. we get 27,982.50. So not much more than the 26,000 that we put in ourselves, which makes sense. You don't earn that much interest in just 2 years. Then we go back and grab a copy of the compound interest formula. This is the end of 2 years. Maybe I should just highlight this. Now we're on the green part, the 16 years. So we're taking this amount and just watching because we're not actually spending childcare money anymore. We get 61,082.29. So one reason why it feels like it's hard to put kids in college is the long-term weight, so to speak, of paying for childcare for 2 years is the same as like $61,000 of money when your kid is 18 that could have gone to college. There's not much practical application of this problem. A household that is able to have an adult stay home and take care of kids can do that and say, hey, I don't have to go to work and work so hard and have almost all of that money go right back to pay for childcare. And a household that can't do that isn't going to be able to. But you can see the benefit of that, that if you can not spend money on childcare and instead be saving, it'll make paying for the kids' college a lot easier in the